Can you see my screen?
Yeah, I can.
Okay. Hi, everyone. This is Maram Elwakeel, and this is my capstone project for this quarter, Hope Speech Classification. This is going to be my agenda for today. I'm going to start with the problem statement, motivation, background, related work, approach, data collection, data analysis, findings, conclusions, future work, key references, and then Q&A. Over the past few years, many studies have focused on solving harmful content problem through hate speech detection, but very few focused on identifying hope speech. So this project discusses various machine learning approaches to identify a sentence as a hope speech, non-hope speech, or neutral sentence. By accurately classifying and promoting hope speech, we can contribute to a more uplifting online environment and foster constructive discussions. As we all know, the internet plays a significant role in shaping public opinion, and the presence of negativity and hate speech can have harmful real-world consequences. For the background, the internet is full of both good and bad content, but most of the work that has been done is focusing on the bad content or removing the bad content from being online, but we should also focus on promoting good content as well. So this project proposes a paradigm shift by introducing a model for hope speech classification, targeting web content that counters hostility on social media, serves as a catalyst for positive change, community building, and inspiring actions on critical issues. These are some of the related work that has been done. So in 2020, the HOPE EDI dataset was introduced by Chakrabarty. In 2021, there was Transformer CNN model and cross-lingual representation learning. And in 2023, there was like two-level HOPE speech detection. So this is the approach I followed. I started by data exploration and pre-processing. I loaded and examined the HOPE dataset, the HOPE EDI dataset. The second step is extracting the feature by transforming the text into a numerical feature using CF-IDF. And then model selection and training. I tried like different machine learning models such as SVM, KNN, KGBoost, Random Forest, and used them all on the training set. And then, of course, the model evaluation by evaluating the model performance on the testing set, and then analyzing how the model performed. And then there's also like continuous improvement. So I used the HOPE EDI dataset, which was introduced by Chakrabarty in 2020. This dataset represents a pioneering effort in the domain of hope speech detection, encompassing over 59,000 comments extracted from YouTube. So here's an example. So this sentence is a comment on YouTube video. It's classified as a hope speech. This sentence is a non-hope speech. This sentence is not English or non-English. By doing the data analysis, I found that the hope speech dataset leans heavily towards the non-hope speech, as we can see here in the graph. So there was like 91% for non-hope speech, 8.6 only for hope speech, and only a small amount, like 0.1 for non-English. So it was like the non-hope speech was really dominating. So by using the different machine learning models, as I said, support vector machine, naive Bayes, KGBoost, random forest. KGBoost and random forest are ensemble machine learnings techniques, and KNN. So they all did like a good performance or a good accuracy, but the support vector machine had the highest accuracy for 92.16%. Naive Bayes had an accuracy of 90.36. Random forest, KGBoost, KNN. They did like balanced performance for 91 varying strength. The findings underscore the complexity of Hope speech classification, highlighting the need for model refinement, particularly in handling multilingual content and nonsense expressions of hopes across diverse linguistic contexts. So, in conclusion, the Hope speech classification is a tricky task. Like, it's important to aim for a positive a more positive online world, but like to understand like the different comments and different expressions, it's really important to do that. And like the different models I tested, like SVM, Naive Bayes, Random Forest Scan, and KG Boost, they all had like good accuracies over 90%, but they didn't do well with different or non-English content. So for future work, this I really need to focus on the non-English content and maybe fine-tune the models to like be able to handle diverse languages. Maybe also explore different maybe CNN, convolution neural networks, or recurrent models for even getting a better accuracy and update models constantly. These are my references. Any questions? Okay, so moving on, since there's like no questions, Priyanka, would you like to present?
Yeah, ma'am. Yeah, I'll go ahead and present my part.
Go ahead.
Uh, can you guys see my screen?
Yeah, we can see it.
Hi everyone. This is Priyanka. My capstone project is based on stroke prediction using AI models. Uh, so agenda is I'm going to talk about what's the problem statement, motivation, related work, approach, design and implementation, data collection, data analysis and findings. Let me introduce my topic. Like, what is a stroke? A cerebrovascular accident, also known as a stroke, these are the second leading cause of death worldwide and the third leading cause of disability. The World Health Organization declares stroke as one of the growing crises that is receiving very little attention to date. So, early awareness of having this illness has proved to be a beneficial for prevention and treatment. Problem statement is like, what is the importance of early detection? So if we detect the disease as soon as possible, like we can try to control by taking other action. So there are limitations in our traditional tools. Like there are already a few tools to find out the stroke prediction, uh, but the accuracy is less compared to recent tools. So I will work on the accuracy of the tools. So motivation, the global stroke impact. Stroke affect health, economies, and livelihoods worldwide. Conventional limitations. Existing stroke risk assessment tools fall short. As I told, like existing stroke detection tools are not that accurate. Frequent failure to detect at risk individual in time. Related work, like I have gone through multiple papers. Here I compared three different papers which I have gone through. In that, like authors used different AI models to um, predict predict. So in first paper, author used random forest, SVM, logistic regression, deep neural network, and KNN model, and they could achieve 82.5 accuracy. In second paper, author used gradient boosting, decision tree, and SVM model, and they could able to achieve 75.3, which is less compared to the other paper. Um, in paper 3, used logistic regression, random forest, conventional neural network, and a recurrent neural network model, and they could achieve 88.7%, which is high compared to other two papers. So what approach I'm going through is data integration. To overcome the limitation of existing risk prediction models, we will gather the diverse data resource, including medical records, lifestyles, factors, genetic information, and real-time health monitoring data. These resources will be integrated into unfilled unified platform to create a holistic view of individual's health profile. So featuring engineering is something, it has to deal with the complexity of diverse data types, require advanced feature engineering techniques. So these machine learning models, I am using like 5 different machine learning AI models. I will be explaining in the upcoming slides. This real-time monitoring is to enable real-time risk prediction. We will develop efficient and scalable algorithm that can continuously monitor and update risk assessment as new patient data. So data collections. I have a data set which is I downloaded from a Kaggle. It contains a, total number of like 500 and uh, 5110 rows, data of with 11 columns, and had attributes. Attributes consist of different sorry. So attribute consists like ID, gender, age, hypertension, heart diseases, have ever married, work type, resident type, average glucose level, BMI, smoking status, and stroke. Like these data of individual persons. Like we have 510 different data. So in data analysis, we analyze like what we have in our data set, like how many rows we have, and how many columns, and what is the rate of stroke in all the data set and all. In data pre-processing, it involves in eliminating the noise and outliners, ensuring efficient model training. Like if we have a repeated data, yeah, we can drop from that. So data analysis is also consisting of label encoding. Label encoding converts string data into a numerical values, making the data set compatible with machine learning algorithms, which typically operate with a numerical input. Handling imbalanced data. Balancing stroke prediction data through undersampling for improved accuracy, reducing class imbalance to 249 entry each. So this is the system architecture. Here we have a user. The person using our web application will be the user who wants to know whether they have a risk of having a stroke or not. So we will take input through web app. The user will be asked to about some details regarding their gender, age, hypertension, heart disease, etc. Kind of attributes. All those details are necessary for the prediction of stroke possibility for that individual. So user defined input tested against ML model, total of like 5. I have trained 5 model. I achieved highest accuracy in SVM model, so I'm using SVM model here. So we will load the data into SVM model. Then model predicts the data, and will get the outcome. If uh, if through our web application, the user will get to know about the outcome of its input data. The outcome for no stroke will be displayed as a no stroke risk diagnosed. uh, Through our web application, the user will get to know about their outcome. Like if they as no stroke, they'll get as a no stroke risk diagnosed. If they get a stroke, then stroke risk diagnosed. This is our architecture. So about machine learning algorithm, the system has been implemented using 5 different machine learning algorithms to obtain the best possible outcome and accuracy. Machine learning model has been developed using logistic regression, support vector machine, KNN, decision tree, and finally random forest algorithms. So the lowest accuracy is given by the decision tree algorithm, and highest accuracy is given by SVM. I have plot the graph using matplotlib here. So after training the model, so we are loading the scalar data from a serialized file called pickle format, located at the specific path. After loading the data, like we are loading a machine learning model, the highest accuracy is given by SVM algorithm. So we'll import the SVM trained model for testing against the user defined data using joblib. It is about a simple GUI which I developed for this project. I have used front end. In front end, I've used HTML, CSS, and Bootstrap. As a framework, I used a Flask as a router. Like I used Python API to build a web application. Libraries I have used are Panda, NumPy, Seaborn, Matplotlib, Pickle, and Joblib. So this is our GUI working. I'm going to show the demo. GUI take input data from user, predict outcome using pre-trained SVM model on user data. The obtained result, then it reflect back on the web page through the Flask application for the user to see prediction. So this is the conclusion. Efficient stroke prediction. Implemented system utilizes trained machine learning algorithm to predict stroke accurately with a high accuracy rate of 93.93 using SVM model. Uh, we have a user-centric design that employs a simple and empathetic user interface, ensuring a positive experience for both users. So I'm done with the presentation. I'm going to show the demo of my code. Uh, this is the code. So if I run this app.py file, yeah, here is the GUI. So user should give their value here. For gender, 0 is female and age is 30. Okay, I have a reuse data. So used given data, like it predicted as you have been diagnosed with no stroke risk. Congratulations. Let me change some of the data so that I can get a other result also. Yeah, I've changed few user input, so I'm getting now you have been diagnosed with stroke risk. Yeah, thank you. I'm done with my presentation and demo. Like anyone have, please let me know if anyone has any question.
Does anyone have any questions for Priyanka? Okay, thank you, Priyanka, for your presentation. Vu, would you like to present your work?
Hi, yeah, I'm ready for my
Okay,
presentation.
go ahead.
Uh, you see my screen?
Yes, we do.
Okay, so hello everybody. So my name is Vo, and today I'm gonna uh, today we'll present about the development of house decoration shopping web application. So this is my capstone project. So this will include the problem statement, motivations, background, related work, approach, uh, design implementation, data collections, data analysis and finding, uh, also the conclusions, future work, and some key reference. So for the introductions, so in the age of the digital transformations, the e-commerce sector grows immensely and alternating the traditional shopping method and improving the customer experience with convenience and choice. Uh, House decorations and interior design has a significant value on market based on the house demanding. So customer they increasingly seek innovative platforms that not only provide the diverse amounts of products, but also brings the high quality of shopping experience. Uh, in this case, the efficient technology is the requirement that can help to build such scalable platforms and with multiple functions. The merge stack is an ideal technology to build such a good shopping web applications. For the background, there are not so many websites focused on home decor. The price tag is usually expensive, and several apps such as Temu and AliExpress have the good retailing model by selling goods that are imported from China with low price, and the model can be applied with house decor either. For the problem statement, this paper is declared to develop an online shopping uh, applications. The application mainly sells house decoration products, and with the house decoration, there are not so many websites concentrate on house decoration with acceptable price, and this causes the less efficiency and convenience. For the motivations, the main purpose of this project is based on the high demand of the housing market in US, and every new house or remodel house needs new decorations. So since the birth rate is always proportional to the housing demand, uh, uh, people will tend to buy more house in the future. So that's why uh, for the approach. Uh, this research will use the most powerful tools merge stack to develop the online shopping web applications. Uh, the paper we explain carefully the development process as well as the all the functions contained, and also the study involves researching the average prices of house goods market to discover the proper price for the website. For the implementation, so I'm gonna use uh, the programming language, which is JavaScript, React library with database is MongoDB. Some several keywords. So in the related work, shopping online is the form of shopping through the website with online payment. It's through the credit card, third-party payment like PayPal, Google Pay. So with this shopping method, it will not be restricted by time and regions. So this can help the customer understand all the informations about the commodities, and the payment can also be performed convenient and quick. Uh, Merge stack will be the technology that is used in this project, and JavaScript is used as the programming language since this is the powerful uh, tool for web development, and React is one of the JavaScript libraries that has the accordant built-ins that serve for front ends. And with MongoDB and Express.js, the application will have a strong database system and backend to provide data for shopping apps, such as images and user profile. And also based on the research of Kuo and Change, the chain of U.S. people go online shopping is about 60% of the internet populations. So, and with the house decoration, this number can be higher due to the high demand in the housing market. And also with the statistics, this is the ideal scenario to develop a shopping web applications. In the data collections, the paper employ a comprehensive data collections approach. There are some aspects to focus on, such as development tool analysis, system architecture, user preferences, performance, and development process. So uh, for the uh, for the tool development tool analysis, I will briefly talk about the merge stack. Uh, so uh, so in this study, we will analyze the tool for the development. We will providing the uh, advantage and disadvantage and the objective of the tool to develop a web applications. In the system architecture, the study will conduct the literature review to analyze and improve the shopping online applications. This paper will review previous academic papers to understand the basic implementations, work on in-depth analysis of merge stack components to optimize for use case. The study also analyzed the user preferences, which is capture the user preferences for house decoration app. The case studies technique will be applied to collect previous survey and usage statistical informations. Also, the development process is to make the application offline with the front end for practical purpose with user interface design and user interactions. In the data analysis, so the merge stack, this is a popular library for web development, and the library comes with 4 factors, which are MongoDB, Express.js, React, and Node.js. The library is based on JavaScript, so it's convenient for all programmer. So in the system architecture, the app will contain some components, screens for navigations, and app.js as the main file. So this is one of the example of the main screen, and the screen will include the uh, product screen, login screen, and uh, also there's some components such as user rating, user review. Yes. In the development phase, I'm gonna implement in the implementations. I'm gonna import some basic library, and the app.js file will import the components that were developed, such as product and rating, and the navigator such as routers and browser I use to move around pages. So for the fighting, uh, in the future work, this paper can add some AI or virtual assistant, which can help the customer like 24/7, uh, and the helping center also the necessary in the future, which can support the customer whenever they have questions or problem with the order. In the conclusions, so this study might bring a good home decorations application that can satisfy customers with cheap house decor into the market, and it can solve the problem in which there are not so many home decor platform, and the research can meet the house demand rating. This is some key references. Okay. Do I have any questions? Any questions?
Okay, thank you, Vu. So no questions.
Okay.
Okay, so thank you everyone, and congratulations on graduation, Vu and Priyanka. And thank you, Scott and Vaishnavi, for attending. Do you wanna ask about anything? Okay, perfect. Let's end our session. Thank you so much.
Thank
Thank
you,
you.
man.
Thank
Have
you.
a good day.